Okay, number 1 wants me to evaluate my expression on the calculator, and it wants me to round to 2 decimal places when appropriate. The first thing I want to tell you guys how to do is how to get the cube root on the calculator. You go to Math, and then I believe it's choice 4. Yes, choice 4 is the cube root. So I want to do that. So I'm going to go to choice 4, and then type in my number, which is 17,859. It wants to 2 decimal places, so this is going to be 26.14. On the quiz, I noticed a lot of people not rounding correctly. This number is the 3 is where I should be rounding at, because the number to the right of it is more than 5. It rounds up to a 4. I'm going to do number 3 because it's similar, and then I'll move on to 2 and 4. So 3 works the same way. I go Math, choice 4, and then I type in my number, 2197. Which gives me, this one comes out nicely, it's just 13. On the other side, I am evaluating the expression using the calculator, and I want to round my answer to 2 decimal places when appropriate. I just type in my number, and then I go up to my exponent button, and then I type in the exponent, so -7/11. I want to not type it like this. I want to type it in parentheses. Yours might, since you're using a newer calculator, I might just leave it all up there in the exponent, but mine is old, so it won't. Then I hit enter. 2 decimal places is 0.05. Same thing with number 4. I'm going to do 59 to the, in parentheses, 3/4. Hit enter. 2 decimal places would turn that first 8 into a 9, so I have 21.29. Numbers 5 and 6 are talking about transformations, and 5, 6, 7, and 8 are all talking about transformations. Number 5, the first thing that happens is my vertical stretch. The second thing that happens is a translation 4 units up. So I'm going to start with my vertical stretch. That is going to multiply everything by a scale factor of 5. So I have cube root x plus 2 minus 1, the 5 outside. The 5 distributes in, so I have 5. I can't actually go into a cube root, so it stays out. Times the cube root of x plus 2. And then I have 5 times the -1, which gives me -5. My second step is then the translation 4 units up. Up and down goes outside. So I have 5 cube root x plus 2 minus 5, and then I want to add 4. Outside is the same. I combine like terms, so I have 5 cube root of x plus 2. -5 plus 4 is -1. I do not want to combine in here. I treat the cube root like parentheses, so nothing goes in, nothing goes out. The only thing that can change it is left and right. And this was now called g of x, now that I've made all my changes. Okay. Number 6, I am going 3 units down, 2 units left, and then this one has a third step, a reflection in the x-axis. So my first change is 3 units down, so that is going to subtract 3 from the end of this. So I wrote that out. Then I actually do it. Square root of x plus 7. 1 minus 3 gives me -2. My second step is 2 units left. Left and right are opposite signs inside. That is kind of off the screen. So I have 3 square root of x plus 7, and then 2 units left would normally be negative. Opposite sign is plus 2, and the minus 2 from before stays out there. I want to combine like terms on the inside. 7 plus 2 is 9. And then I have a reflection in the x-axis. I always want to treat reflections in the x-axis like vertical stretches. So this is 3, ugly 3. So I am going to put everything in parentheses and then distribute in. So 3 square root of x plus 9 is one whole piece, so we'll only have to change the sign on that once, the outside. And then the the negative times the -2 turns it into a positive 2. And this is g of x. I know back when we were doing transformations on functions in the earlier chapters, Lots of people would remember the negative sign up front, but would forget to change the sign at the end. So that's where most people lost their points. Pay attention to this when you take the test. 7 and 8 are transformations again. First one is stretch and up and down. So my first one, I do 2, and then parentheses, cube root of x minus 4, and then minus 8, close my parentheses, distribute. So it turns into 2 cube root x minus 4. And then the second part is 2 times negative 8, which turns into negative 16. The second step is 2 units down, so that subtracts 2 from the end. Negative 16 minus 2 is negative 18. I rename this g of x, and I am good. 8 has 3 steps again. And reflection. Okay, my first step is a translation 5 units up, so I want to add 5 to the end. Negative 4 plus 5 gives me positive 1. Then I want to go 3 units right. That right is normally positive, so opposite of positive is negative 3. And then I still have my plus 1 outside. Combine like terms inside, I have 2 square root of x plus 4. And then plus 1 outside the radical. My final step is to reflect in the x-axis, so I treat this like a vertical stretch or shrink. I distribute in. I have negative 2 square root of x plus 4, x. And then negative times a positive turns it into a negative 1. And then I just want to give my function the name g of x. Moving on to the next page, domain and range. To find domain, this is where I plug into for square roots, so even radicals. I take the inside and set it greater than or equal to 0. So I'm going to take, for my domain, I'm going to take x plus 4 and set it greater than or equal to 0. I solve. I subtract 4 on both sides. I have x is greater than or equal to negative 4 for my domain. For my range, don't know why I wrote up the word range and not domain. I look at my outside number, and it's greater than this. So it's going to be y is greater than or equal to negative 7. Okay. Odd radicals are both all real numbers for domain and range. So this one is an odd radical. My domain is going to be all real numbers. And my range is also going to be all real numbers. I did it again. Okay. This one has an even radical, so I'm going to take the inside piece and set it greater than or equal to 0. I add 6 to both sides. X has to be greater than or equal to 6 for my domain. For my range, I look at the outside piece. It's 3. So y has to be greater than or equal to 3. 12, odd radical. So domain and range are both all real numbers. Without the range. Numbers 13, 14, 15, and 16 all want me to find my real solutions. Odd. I'm going to write this off to the side. All of these will have one solution, actually. I'm not going to write this as a note. So I want to cube it. So I have x minus 3, because that gets rid of the radical. Negative 4 cubed is negative 64. Then I want to add 3 to both sides, and I get x equals negative 61. Number 14, I raise them both to the 4th power. I get x minus 6 on the left. 4 to the 4th is 256. If I forgot, remember I could type this into the calculator. To get x alone, I want to add 6 to both sides. And I get x equals 262. Okay, 15 and 16 are going to work the same ways. 15, I cube both sides. I get x plus 7 on the left. 3 cubed is 27. I subtract 7 on both sides. X equals 20. Over here, raise it to the 4th power. I have x minus 2 equals 16. I add 2 to both sides. X equals 18. Okay. These are the ones where I can have multiple solutions. It wants me to find the real solutions, so I have to check my answers. And then I need to round to 2 decimal places when appropriate. So this one, to get rid of the radical, I'm going to square both sides. On the left, I get 7x minus 26. On the right, remember I'm having x minus 2 times x minus 2, which gives me x squared, negative 2x, and positive 4. If I combine like terms, it'll give me x squared minus 4x plus 4. I want to get everything over to the same side, so I subtract 7x on both sides. I have negative 26 equals x squared minus 11x plus 4. Add the 26 to both sides. I have 0 equals x squared minus 11x plus 30. I look for my two numbers that multiply to 30 and add up to negative 11. It's going to be negative 5. And negative 6. I take those and set those equal to 0. I get x equals 5, x equals 6. Then I want to go ahead and check. Sorry, there's not enough room here. So I have square root of 7 times 5. I took the 5 from one of the numbers I'm checking. Minus 26 equals 5 minus 2. 7 times 5 is 35, minus 26. 5 minus 2 is 3. 25 minus 6 is 9. Square root of 9 equals 3. I'm going to do the other check over here. So I'm going to plug in 6. I have 7 times 6 minus 26. And that should equal 6 minus 2. I'm really sorry about the room again. 7 times 6 is 42. Minus 26 equals 4. 42 minus 26 is 16. Square root of 16 equals 4. This one checks out. Over here, I want to, this one, my answer should be a reduced radical, so I should simplify it. I'm going to divide both sides by 6. I get x to the 4th equals 405. Then I want to take the 4th root. Off to the side, I'm going to do my factor tree. 405 ends in a 5, so I know 5 is one of my factors. I'm going to divide 405 by 5 on my calculator. I get 81. 81 factors to 9 and 9. 3 and 3. 3 and 3. I have a group of 4 3s. So I have x equals, because it was even, I have plus or minus. And then I'm going to have 3 on the outside. Losers stay on the inside. So 5 is left over on the inside. Okay. Number 19 is like 17. I want to start by squaring both sides. I get 4x minus 19. X minus 4 squared is x squared minus 8x plus 16. If you want to know how, you can double check my work by doing the box method. I'm just trying to save room since I know I ran out last time. I want to move everything over to the same side, so I subtract 4x on both sides. I have negative 19 equals x squared minus 12x plus 16. Ugly 16. I gotta work that one out. Then I want to add 19 to both sides. I get 0 equals x squared minus 12x plus 35. I'm going to figure out which two numbers multiply to 35. That adds to negative 12. That is going to be negative 5 and negative 7. Set those equal to 0. Gets me x equals 5, x equals 7. I want to go check those. So the square root of 4 times 5 minus 19 should equal 5 minus 4. 4 times 5 is 20 minus 19. 5 minus 4 is 1. 20 minus 19 is 1. Square root of 1 is 1. Same thing with 7. I have 4 times 7 minus 19 equals 7 minus 4. 4 times 7 is 28 minus 19. 7 minus 4 is 3. Then I want to do 28 minus 19, which gives me 9. Square root of 9 is 3. So both of these are my answers, 5 and 7. Okay. 20, I need to take the root myself. I want to start off by dividing both sides by 4. I have x to the 4th equals 192. Then I want to go do my factor tree. It's even, so I take out a 2. 192 divided by 4 is 81. I know this branch is going to break down to 4 3s. So then it's going to be x. No, I want to take the 4th root. Equals, plus or minus. 3's go outside. 4th root. Loser stays inside. 2. Okay. Number 21 wants me to find the extraneous solution. So the one that doesn't work. So I solve it. I square both sides. I get 63 plus 2x equals x squared. I want to subtract everything over to the other side. Which gives me 0 equals x squared minus 2x minus 63. I want to look for what multiplies to negative 63 and adds to negative 2. That is going to be negative 9 and positive 7. I set each of those equal to 0. And I get x equals 9, x equals negative 7. And now I want to go ahead and do my check. This question is trying to trick me. I'm looking for the one that doesn't work. So, the one that does work is not my answer for this question. I'm going to plug in 9. So I have square root of 63 plus 2 times 9 equals 9. So I have the square root of 63. 2 times 9 is 18. Should equal 9. Square root of 63 plus 18 is 81. Square root of 81 equals 9. That works. That is not my answer. Then I'm going to do the same thing with negative 7. So I have square root of 63 plus, that should have been a 2, times negative 7 should equal negative 7. Square root of 63 minus 14. And then I have equaling negative 7. 63 minus 14 is 49 equals negative 7. This does not work because when you take a square root of a number, you always assume it is positive. So my extraneous solution is x equals negative 7. 22 works the same way. So I want to start off by squaring both sides. I have x minus 1 on the left. X squared minus 14x plus 49. I can use the box method to check my work there. Then I want to get everything over, so I subtract x on both sides. I have, nope. Negative 1 equals x squared minus 15x plus 49. Add 1. I get 0 equals x squared minus 15x plus 50. I want to look for my two factors. It's going to be x minus 5, x minus 10. Set my factors equal to 0. Gets me x equals 5, x equals 10. I'm going to check my answers here. So I have the square root of 5 minus 1. and I want to check to make sure that it equals 5 minus 7. 5 minus 1 is 4. 5 minus 7 is negative 2. Square root of 4 is not negative 2. I have found my extraneous solution. No need to go further. Okay, so on these ones I'm doing function operations, and then I am plugging in values. So the first thing I want to do is I want to find the addition of the two functions. So I have 3x to the 2/5 plus negative x to the 2/5. They have the same exponent, so I can add them. This is the same thing as 3 minus 1, which gives me 2x to the 2/5. Now that I know what they are added together, I can just plug in 4 for x. So I have 2 times 4 to the 2/5. I can type this straight into my calculator. That's not on the screen. So I have 2 parentheses 4, 2. I have to put mine in parentheses. What are you? And it gives me 3.48. I can do the same thing with subtraction. So I'm going to have 3x to the 2/5 minus, and then negative x to the 2/5. So the same thing as adding. So I have 4x to the 2/5 as my function. And then I want to plug in negative 243 for x. 243. Okay, I want to type that into the calculator. Nope, wrong negative. Gives me 36. Same thing down here, except I have different numbers. I'm going to have 3x to the 1/3 plus negative 5x to the 1/3. Combine them, so I have positive 3, negative 5, equals negative 2x to the 1/3. Then over here, I plug in the 7 for x, and I type it into my calculator. Gives me negative 3.83. I want to do subtraction. So I have 3x to the 1/3 minus negative 5x to the 1/3. Turns this positive, so I add them. 8x to the 1/3. And then I want to plug in negative 64 for my x. And I want to type this into the calculator. It gives me negative 32. Okay. Moving on, these function compositions are multiplication and division. So I have 3 square root of x times 2x squared. I want to start off by rewriting this x as a 1/2 exponent. I can multiply my big numbers. Gives me 6. For my x's, I want to add them. So I have 1/2 plus 2. I'm going to turn 2 into a fraction. So I'm going to multiply by 2 over 2, which will give me 1/2 plus 4 over 2. Gives me 5/2. So my answer here is 6x to the 5/2. Second part, I plug in. So 6 times 4 to the 5/2. To the 5/2 gives me 192. Okay, I'm going to divide them, but instead of writing 3 square root of x, I'm going to use the 3x. So 1/2. And I have over 2x squared. This one I want to subtract my exponent, so I have 1/2 minus 2. So I want to multiply the 2 by 2 over 2 again. This time I have 1/2 minus 4/2, which gives me negative 3/2. That means x is on the bottom. So the numbers don't simplify, so I have 3 over 2. Because the exponent was negative, it's going to go on the bottom and become positive. That's my answer for this one. This one I want to plug in the 9. So I have 3 over 2 times 9 to the 3 halves. So when I type this in my calculator, I want to be very careful. I have 3 on the top. I want to do 2 sets of parentheses. Or no, 1 set of parentheses. I want to put everything in a parenthesis, and then I get the duplicate when I put the 9 in. This one gives me 0.555 repeating. If I go math fraction, it gives me 1 over 18. Okay. 26 is going to work the same way. I have 5 square root of x times negative 3x squared. I want to rewrite that as 5x to the 1/2 times negative 3x squared. I multiply my big numbers, which gives me negative 15. Add my exponents, I have 1/2 plus 2. We know from the previous problem that this is 5/2. Okay, second part, I plug in 9. Type this in my calculator. I'm going to have negative 15 times 9 to the 5/2, which gives me a negative 3,645. Next one is division, so I have 5x to the 1/2 over negative 3x squared. I want to subtract these fractions, which I know gives me negative 3/4. So the 5 stays on top, the negative 3 stays on the bottom, and the exponent will move to the bottom and become positive. Then I want to plug in 5. So I have 5 over negative 3 times 5 to the 3/4. I want to type this in the calculator. That should have been 3. Then I go math fraction. This one doesn't turn into a nice fraction. So I have negative, this is going to round to 0.50. Moving on, these want me to find the inverse functions. So, to find inverse functions, I always start off by switching x and y. I'm going to have x equals 2 cube root y plus 5 minus 8. Then I want to start by adding 8 to both sides. I have x plus 8 equals 2 cube root of y plus 5. Divide both sides by 2. X plus 8 over 2 equals cube root y plus 5. Next, I want to get rid of the cube root by cubing both sides. X plus 8 over 2 cubed equals y plus 5. Subtract 5. Y equals x plus 8 over 2 cubed minus 5. Over here, that was off this one, I'm sorry. I am finding the inverse of a cube. So I'm going to have x equals y cubed plus 125. I start off by subtracting 125 on both sides. X minus 125 equals y cubed. Then I take the cube root. I get the cube root of x minus 125 equals y. Down here, switch my variables. I have x equals 4, cube root y minus 3 plus 4. Start by subtracting 4 on both sides. X minus 4 equals 4, cube root y minus 3. Divide both sides by 4. I have x minus 4 over 4 equals cube root y minus 3. Then I want to cube both sides. I have x minus 4 over 4 cubed equals y minus 3. I want to add 3 to both sides. I get y equals x minus 4 over 4 cubed plus 3. Over here, I want to start by switching my variables. Then I want to subtract 8 on both sides. I get x minus 8 equals y cubed. Take the cube root. Y equals the cube root of x minus 8. So for number 31, it wants me to find the inverse of this function. Inverse meaning solve for r. And then it wants me to figure out the radius once I know my volume. So in this instance, I'm going to leave all my variables alone and just get r alone. So first thing I want to do is I want to get rid of this fraction. I am going to multiply both sides by 3/4. That gets me 3v4 equals pi r cubed. Then I want to divide both sides by pi. Pi will go with the 4 on the bottom. Then I have r cubed, so I have to find the cube root. R equals the cube root of 3v over 4 pi. That is my inverse. And then I want to figure out the radius for the volume of 400 cubic meters. So I'm going to plug in 400 cubic meters for V. I would like to simplify this first. So I have r equals the cube root of 1200 pi over 4 pi. 1200 can be divided by 400, or 4, and the pi's will cancel out. Gives me r equals the cube root of 300. I want to round my answer to 2 decimal places, so that means I need to type it on my calculator. I go math, choice 4, nope, 300. Which gives me 6.69 meters cubed. Okay. Same thing for this one. It wants me to find the inverse. That is what I did on part A, so I'm not going to do my work again. I'm just going to write my answer. On the test, I need to show my work. So make sure you do that, or else I will mark you off the point. On part B, this time I'm plugging in 700 for V, or 700 pi. So I have r equals the cube root of 3 times 700 pi over 4 pi. I want to simplify this, so I have 2100 pi over 4 pi. The pi's will cancel out. 2100 divided by 4, 525. This is cube root. Then I want to find the cube root of 525. Math, choice 4, 525. 8.07 rounds because of the 7.